We'll talk about creating evolutionary design and architecture in this presentation. We'll talk a little bit about architecture and then talk about why to evolve it, and then take a look at several ways that we can actually make the architecture and the design evolutionary. But the first question I want to start out with is, what's architecture? Go around and ask your colleagues, hey, what's architecture? And then look at the blank and the silence that follows. That's pretty natural. That's the normal answer I get whenever I ask people what's architecture. Well, the reason for that is architecture is something we could feel, but we can never explain it, right? Well, the reason for that is it tends to be really vague to define it. We kind of know what it is, but what is the boundary? How do we define it? Well, the way I look at it is a design is rather, relatively speaking, a low-level detail. We are interested in a class level design. We are interested in how a group of classes communicate with each other. I'm interested in a method level design. What are the parameters I'm going to take for this method? What should I return? How do I break this? How do I modularize these methods? Should I apply certain design principles and maybe divide this into multiple small methods? Am I really going to implement this algorithm recursively, or am I going to use a pure iteration to do it? To me, those are design issues. An architectural issue, on the other hand, is at a much higher level, relatively speaking. We're talking about components. We're talking about components with potentially interfaces. And components could be a group of classes, a collection of classes that are cohesive and are really intended to provide one certain functionality or a service. In a microservices architecture, we could have microservices that can run on a deployment setting, maybe on the cloud potentially, but those are going to communicate with each other to provide the application service or the workflow we are interested in. Maybe we are getting a request for invoice to be processed. Maybe it's got to talk to a purchasing order system. Maybe it has to talk to other systems. Maybe it has to communicate with the system that's going to get the approval necessary for this invoice to be processed. And so in an architectural level, we're going to have all these different components where different component may provide different services. Potentially these components may be sitting on a same physical machine. They could be distributed geographically across. They could be clustered, they could be load balanced, what have you. So these are really at the component level, system and subsystem level details. So an architectural representation is a rather high level at the system level, how major pieces are communicating between each other and what each of the components' responsibilities are and what their interfaces are. On the other hand, at the design level, we are interested in how individual things that make up these components are defined to be what their responsibilities are, how they communicate with each other, and drilling down into lower level of details right from there. So that's the distinction between architecture and the design that we are really interested in. But the question then is, how do we create an architecture? Now, look around projects and ask people, when do they normally create architecture? And this is what they're going to tell you most often when they create the architecture, is if you consider a timeline on a project. Let's say on the left over here is when the project has not started yet. And then of course this timeline is when eventually this project would be completed. Now, back in time, this is decades ago, this timeline for a project was several years. I personally worked on projects where nothing was delivered for 10 full years. Those are called pathway to hell development process. Well, today we are looking at developing and releasing in a short amount of time. Projects get developed and released within sometimes weeks or months. Maybe within a quarter. Every quarter we will be releasing a particular version. Every 6 months, or definitely at least a few releases in a year. If companies are doing continuous deployment, then that could be several deployments in a day. As soon as a little feature is developed, you might be releasing it. But ignoring that for a minute, you could consider the initial release of a product. Well, it doesn't matter what the product is, if it's of significance, if it's non-trivial, if it's doing something substantial, I'm assuming it's going to take you at least a few weeks to maybe a few months. It's not unusual to say, oh, at least 2-3 months for a very small size project to maybe about 5 to 6 months potentially for a large size project. But in any case, if this is the timeline, what are the decisions we make and when do we make? Well, one of the things we would particularly make is the architectural decisions. Go around and ask people if architecture is important, and I'm sure everybody would say architecture is extremely important. In fact, it's so important, you better not get it wrong. You better not mess up with it. Now, typically, architecture, unfortunately, sometimes becomes a responsibility of an architect or a senior architect or an application architect. Now, these people, if there's a designated title for these people, they take the responsibility to create the architecture, and they take it as a burden on themselves to deliver an architecture. And that could be a problem in itself. But typically, ask people, when do you create the architecture? And most of the time we will tell that we create the architecture right there, way in the beginning. This point in time often tends to be varying quite a bit, but unfortunately on traditional projects, this tends to go towards the left, unfortunately, not towards the right. So people tend to create architecture even before they get started on projects. I remember I came across a project where the client came back and said, we got 2 requirements for this application. We want this to be highly concurrent, and we want this to be deployed on the cloud. And so these are very significant architectural decisions in it, that it should support very high amount of concurrency, and it's got to be on the cloud. And I asked them, what does your product actually do? And they said, we don't know that yet. We're trying to figure that out. But we know very well it's got to be on the cloud, and it's got to be very highly concurrent. Well, these decisions can be disastrous sometimes. Maybe it's got to be on the cloud. Maybe it doesn't have to be on the cloud in the beginning. And I've come across projects where concurrency was not an issue at all. But the teams have spent months and months and months creating concurrency to an application where concurrency was not an issue at all. And then they spend years after that fixing errors and the nightmare that ensures from implementing concurrency solutions. So in other words, a lot of times architectural decisions are unfortunately made way early in the game. Ignore that for a few minutes, we'll come back to it. If you consider a project's timeline, now when do we know the most about this project? We probably would agree it looks something like this. When we start out, we don't know a whole lot about this project. We think we know, but there's a lot of this uncertainty, this fog in front of us. We know what we have to do, but we don't know the details of just about anything. We're not able to put our fingers on it. And as a result, it becomes really hard for us to really nail down the details. And as the project proceeds, about 40 to 50% into the project time, we begin to make a lot more sense. Things begin to fall into place. We're able to answer questions. We're able to say with more certainty what things actually mean. And of course, about 60 to 70 or 80% of the project, most of the things are fairly clear at that point because we have understood and we have seen in development what these things are. Now let's put these 2 pictures together. We are saying that architecture is extremely important. You better not get it wrong. It has a very significant impact, and we're going to do all of those important things when we have the least clue about what we are trying to do. What does that actually mean? Well, unfortunately, that means it's a very high risk. We cannot possibly, there's no logic here. If you apply and see if this is rational, this is irrational thinking, isn't it? It is where we say we are going to do what is the most important thing or one of the most important things when we have no clue about what we are trying to do. So this is very high risk. It's extremely important that we allow the architecture to really evolve. So that doesn't mean, I'm not suggesting by any means that we discard architecture. No, that's not what I'm saying. It's very important for us to come up with an architecture. However, we have to have the courage, we have to have the professional discipline to label that not as an architecture, but to label that as an architectural draft. We need to say this is our architectural vision. A really good architect, the one who is responsible to create the architecture, should do a couple of things. The very first thing is the architect should not create the architecture, but should facilitate the creation of architecture with the collaboration of the team. There's a fantastic article by Martin Fowler. I cannot recommend this enough. And Martin Fowler's article is called "Who Needs an Architect?" And this is a fantastic article. And this was written, about a few years ago. It's a very short piece of article, about 3.5 pages long. But it's an article I highly recommend. Who Needs an Architect? And in this he describes about the role of a really good architect. He talks about one architect. Well, actually, you know what? I won't spoil the thrill of reading it for you. I suggest you read this. But he talks about, in a sense, a good architect is a person who puts himself out of the job by creating a team that can create architecture. He says the role of a good architect is the role of a mentor who really facilitates the team to learn and advance and create the architecture. So given that, we really want to be able to create an architecture that actually evolves, and the job of the architect is not to deliver an architecture, but to facilitate the creation of an architectural draft in the beginning. So if we can create an architectural draft in the beginning, then through the sprints or the iterations of the project, we can evolve that architecture. We can then come back and see if the decisions we are making along the way concur with the initial suggestions that we have created in the architectural draft. And that's what I want to emphasize here, the word suggestion rather than decision. The initial architectural vision, the initial architectural diagrams, the initial architectural draft we create that's exactly what they are. They are suggestions. And they are done based on what we know at that time. Here is what makes sense based on what we know, but we will be very quick to decide and change things as we evolve the application. Now, how do you create an architectural suggestion but then be able to evolve it? Well, you don't want to commit to anything until you no longer can stay without committing. We'll talk more about these things as we go along. So the idea really is, it's very critical to evolve the architecture. Now, what is the risk of not evolving? What's the risk of committing to an architecture way in the beginning? Well, oftentimes this comes when there is an architect whose responsibility as perceived in the organization, this is rather political sometimes, or a misunderstanding, or a lack of really understanding the reality of software. And if the company and the architect believe that the job of the architect is to deliver the architecture, while the architect develops an architecture way in the beginning, hands off the architecture and says, you will implement this. And oftentimes this is very dangerous because the decisions made at that level, rather than being suggestions, end up being implemented. And so as time goes on, as we understand the details of the project, we tend to deviate from the reality from the architecture point of view, and there's a mismatch between the reality of the project and the architecture. And we make things work eventually, but it comes up back to us as extensibility issues, very high cost of change, high cost of maintenance. Or when you suggest that we want to make a certain change, it becomes cost prohibitive when it comes to making these changes moving forward. So the idea really is, it's very important that we evolve the architecture. The risk of not evolving the architecture is that the architecture and the design end up being disconnected from the realities of the application. And when the architecture and the design are disconnected from the realities of the application, as the application reality evolves, when we have to make certain changes to the application, it becomes incredibly difficult. Programmers don't want to show up to work because they got to change way too much. And when they start changing things, things become very brittle. It breaks and becomes very expensive to put it back into shape and put it back into running. And the cost of testing, it becomes extremely high as well. And the net effect of this is the economic impact. And I want to keep this in mind every single time we develop software. We have to keep the economic impact in mind. If we do not consider the economic impact, then all that we are doing is showing up to work and writing some code, but we need to keep in mind the value that we produce for the business, the value that we produce for the customers, and the cost at which we are providing this value, and that is something we cannot discard. We got to keep that in mind along the way as we develop software applications. So the risk of not evolving is an economic impact, essentially. And of course, it's got a market impact that in turn, we cannot respond to the market events quickly. It can set us at a very great disadvantage in the marketplace. It can make a difference between the company surviving and the company disappearing. I personally have seen some giant companies disappear in the last 4 to 5 years because when their competition, a non-existent competition, shows up with a product which is far superior than their own products, they are not able to respond to these changes. This is something that Taleb talks about in his wonderful book called The Black Swan. A black swan concept is a very important concept in business we need to understand. Well, the word black swan itself, there was a time when humans only knew about swans being white. And imagine the surprise when a human ran into the very first one that was black in color. Well, that basically the concept of black swan is something we never knew existed, and it came as a surprise. Well, in business, the word black swan means an event that is absolutely unpredictable. You could never ever imagine that this could happen, but it does. And there are bad black swans, unfortunately. We don't have to talk about it, but there are really good black swans. Google, for example, Apple. Would you have imagined that, if you were talking to people in the 1970s when other companies ruled the world, would you have imagined that companies like Google and Apple would be the leading companies today? And what would be the company that is the leader in the next 5 years, the next 10 years? If we were to come back in about 5 years from now and ask which company has the absolute precedence in the marketplace, how could we say what it is? Well, that's the beauty of black swans. So you can never predict the black swan. However, the question is not if you can predict it, because you can't, but the question is, how do you respond to black swans when you see them? And the point really is, how quickly can you respond to the marketplace if a competition comes up with an incredibly better product? How do you change what you do and respond to that? Well, there are several issues in it, but one of those issues is architecture. I'll relate back to this later on in the presentation, where I'll give an example of a company that I worked with where their architecture was way limiting. That company doesn't exist today, but I worked with them about 8 years ago, where I was trying desperately to help them to see if they can re-evolve and revitalize what they do, but their architectural and team organization was so really rigid that it was incredibly difficult to make any change at all. And eventually they had to just drag themselves into death and disappear from the marketplace. And mind you, this was one of the most leading companies in the world that doesn't exist today. And such things can happen partly because architectural decisions were way too rigid and made too early and inflexible. You cannot evolve these things. So the risk of not evolving is definitely there. But what is the risk of evolving? Well, one of the risks of evolutionary, the thing that we fear is that when we have an evolutionary architecture, what if we come to a point in time when we have a requirement change and that doesn't fit into the existing architecture? Oh boy, what do we do then? Is it possible that it would completely discard the current existing architecture or the current existing design and jeopardize the entire system and become cost prohibitive to add this particular feature? Well, there are two things to think about when it comes to reducing that risk of evolving. The very first thing is, it doesn't matter whether you pre-create the architecture or you're evolving it. There is always a time when a very drastically, totally unexpected feature might pop up. You cannot really say that would not happen. So the feature randomly popping up is going to be there whether you do evolutionary or you did the upfront architecture and design. However, if we did the evolutionary architecture where we kept things extremely minimum, if we kept things very lightweight, then it is much easier to make this change affordable rather than when we had a complexity built in. That's one thing. Second, ignoring this random popping of some feature. What if these are features we know, we just don't know all the details about these features yet, as I showed in that graph, but we know these features are what we want to implement? Well, typically, the problem is that some features may change drastically. Some features may evolve. Some features may disappear because they no longer are relevant. But we knew a ballpark of what these features are. Well, if that is what you have, if you start arbitrarily taking features and implementing them, obviously you would get into a trouble when you suddenly come across a feature and that doesn't fit into your architecture. That's one of the reasons why we have to prioritize the features in terms of the most architecturally significant and most valuable for the business and start working them down from the most valuable to the least valuable and the most significant impact on architecture, the least one. If we go this route, then the chances of one coming towards the end or way after the middle affecting and jeopardizing the architecture is far less in terms of the risk. So it's important for us to be able to create it in a way that it's actually easier to extend, easier to maintain this. So we want to really deal with it by prioritizing based on the value and the architectural impact of this. Now here's another thing to think about. How do we really reduce the risk of evolving? In the article I mentioned about who needs an architect, Ralph Johnson writes a paragraph about architecture. Well, you could ask people what's architecture once more, and one of the things you will hear is architecture is something that contains decisions that are hard to change. Decisions that are extremely significant, decisions that can be very damaging if they are made in a wrong way. So an architecture is a set of decisions that are really hard to change. An architecture is also defined, Ralph Johnson says, that architecture is a shared knowledge for the team of developers. Notice the word a shared knowledge. An architecture is a shared knowledge. When you have an architecture in a team, you go to the team and ask them, hey, what are we doing? Where does this fit in? And people should be able to relate to the architecture and say, it should be in this component, it should be in that component. This is where it belongs, and here's how things communicate. Architecture is a shared vision. And that also says that architecture should be simple enough for people to understand. Now that is emphasis there is simple enough for people to understand. In a large organization, sometimes people write architectural documentation that runs into hundreds and hundreds of pages. Well, if a document is hundreds of pages, I'm really sorry, nobody reads them. Now, I'll give you a challenge. If you think people actually read it, give them a bulky architectural document, but on the 50th page, staple a $50 bill. Give it to somebody, go back after 2 weeks and say, could I have it back please, and open that page and see if the dollar bill is still, that $50 is still there. I bet you it's still there. And the reason is that people do not read. People do not read that much amount of detail. To me, a good architectural document should be about 5 pages long. It should give a very high level detail, things that people should know. To me, a good document is not a document that gives all the answers. To me, a good document is a document that gives us the right questions to ask. Then we can go around and ask these questions in the team, collaborate and find things from each other. To me, a good architectural document is the one that gives us a direction, but we then collaborate with the team to find the details. So that to me is extremely important in terms of what we communicate in an architecture. Ralph Johnson then says that when we look at an architecture, when we design an architecture, we often create a hierarchy of classes. We create interfaces, we create derived classes, we create all these different things. And then what do we end up doing? We end up creating this massive structure. Why? Well, they say pathway to hell is created on good intentions, and the point really is that we created this because we want to make the system extensible. But in doing so, we created such a monstrous complexity that when a reason comes to evolve and a reason comes to extend this, that very things we put in to make the code extensible, the design extensible, makes it really hard to extend it. And as a result, we find it incredibly difficult to evolve the architecture and the design when the time and the need comes to evolve and extend it. But on the other hand, he says, if you were to create an architecture and design that is minimalistic, as simple as possible, consisting as with the minimum number of things as possible, then when a change happens, then there are fewer things in there that is going to make it harder for you to make the change. There are fewer things to resist the change. It becomes easier to change a simple and minimalistic design than a monstrous complexity that we would have created otherwise. So it's very important for us to be able to create this architecture that is evolutionary. But creating an evolution architecture is not an accidental approach. It's not where you simply ignore this and say, yeah, I'm going to just arrive at the architecture one day. It's got to be a very deliberate effort to create an evolutionary architecture. This is something we got to work towards. So we have to come up with an architectural draft, a vision, a set of suggestions, and say, based on what we know so far, here is an architecture that seems to make sense. Now, to give you an example of this, you could say, here are the languages I'm going to use to create this application. Tell me about this. How many times we decide on a language way before we even know what this application is about? I've seen it way too many times. I've come to teams and asked them, what language are you going to use? Here's the language we're going to use. And why exactly do you want to use that language? And oftentimes, the true reason is, well, that's the one we are most comfortable with. But that may not be the best language to use. Sure, there's a bit of a learning curve to pick up another language. Sure, there's a bit of a learning curve to pick up another library or a tool. But if that is a lot more suitable for the job on hand, wouldn't we be better off using that other language rather than going with the one that we are most comfortable and familiar with? Well, I'll relate this to my own experience. I can reasonably code in about 12 different languages, and I do take pride in the flexibility, the freedom that has been given to me that's a privilege in my opinion, that I have this freedom to choose between these languages that are available. But then you may ask me, what language do I choose? And the short answer is it depends on the project, but I'll talk about this a little later on as to why I chose one language and one framework when I had so many in front of me. Any one of them I'm comfortable using. Why did I pick and choose one of them? And those kinds of decisions we need to know why we are making. But not only is that why we are making those decisions, another question to ask is, when are we making those decisions? If we make those decisions way too early, before we know the details, before we consider other aspects, then we are committing to something way too early, and that could potentially be detrimental. I was talking to one of my clients, and they were using a certain language. I won't mention the language here to create a war, but they were using one particular language. 90% of the teams in this company use that one language. I was talking to one of their VPs, and I asked him, why is this language used so predominantly in your company? And he said, well, this decision was made about 5 years ago, and the way this decision was made is a group of people got together and decided what language they want to use, and then went around and asked questions for which the answer would be that language. And that's how they chose this language. Today, we know that was not a best decision. In fact, today we have other languages in the company, even though smaller number of projects are using these other languages. And over time, this is going to change for sure. But that was a very high-level decision, corporate decision that was made. But it was made in haste without really putting in the effort to really determine it was. And some of these decisions are made based on emotions and preconceived notions rather than technical reasons. And so we need to be very careful making some of these decisions. And so it's got to be a very deliberate effort to say, that's a decision we don't need to make right now. And here are the things we know. Here are the suggestions we have. And we want to take the time and evolve and determine and then commit to some of these as we go along. And the other thing I want to emphasize is when it comes to architecture, it's very important that we do not build an application in architectural layers. This is one of the biggest pitfalls I see in organization. Well, you may see companies that say, oh, we need a messaging bus after all. So we're going to say bus, and we're going to implement the bus for the next 6 months. Then we need a persistence layer. So we're going to say persistence, we'll say persistence layer, DB layer, for example, and we're going to start developing that right here. And then what are we going to do? Well, we obviously need a security layer. So we will say we're going to build a security layer after that, and that's going to take another few months to develop. Or even worse, then you decide, well, after all, we don't want to take 18 months to develop this. So here's an idea. We're going to have a bus team, and we're going to have a persistence team, and we have a security team. And then we're going to have these teams that develop these things in parallel along the way. So these people can be spending the time developing this concurrently. Well, all of these approaches are pathway to hell. And the reason is we are focused here on developing architecture rather than developing application. So yes, have an architectural vision. Yes, have an idea. Yes, have a suggestion. Say that you're going to have a messaging bus. Say that you have a persisting layer. Say that you have a security layer. That's all perfectly fine. And put any number of layers and tiers that you can think of. But once you do, then you start out by saying, all right, now that we have decided that this is the direction we want to go, we're not decided this is what we want to build, this is not set on stone, all we know is the decision is this is the direction we're going to go. But just like any direction, we need to have detours, and sometimes we may have to take a completely different course depending on what we see in front of us. But then you say, we are going to start by building a vertical thin slice of the architecture. Now, in the very beginning, when you start out, you may realize you don't need the messaging bus at all. Well, then don't build it. This sprint doesn't require a messaging bus, so I'm not going to build anything for the messaging bus. And, well, wait a minute, if you do it this way, what do you do in sprint number 5 when you suddenly need a messaging bus? Oh dear, you're not going to have that. Well, this is where the planning of the project comes in. If you were to prioritize your application requirements, stories, in terms of the most valuable to the least valuable, and then look ahead in your project planning. When you're in sprint 5, don't blindly look at sprint 5. Spend part of your time looking at, hey, what's in sprint 6, 7? What's in sprint 8? Are there things that require certain substantial things? Maybe we should do a little prototyping of that. Maybe we should do a little spiking of that in sprint 5. So we gain a little bit more insight so we can start building what we need towards it. And then you start building in vertical slices. So when it comes to the sprint, you say, for this particular user story or for these group of stories, here are the architectural things we need. We are not going to go build that, but we are going to build that. the only part that we vertically need for our application. So as time goes on, we start building these different architectural pieces, and we find that some piece is not needed right now, postpone it. If we find that some piece is not really the way we wanted it to be in the beginning, but this is a better way to do it that way, but evolve each of the pieces, but only based on what your application, real value producing features tell you, and not what we hypothetically, emotionally arrived at and saying that's going to be part of the application. So when we go this route, it becomes a lot more easier to evolve the architecture as time goes on. So what I want to do in the next part of this presentation is get into the details about how do we really make the architecture evolutionary, and there are so many things we can do to make the architecture evolutionary, and we're going to look at several of those ideas and approaches as we get into the next few parts of this presentation.